Hey there, year 11. So in this exercise, we're now going to look at one-to-one functions and implied domains. To start off with, we need to revise again. In our previous lessons, we talked about what a function is. Now, the way I described it at the time is that you can think of a function as like a machine, and the x values that you substitute in can only be a function if the resulting value comes out as only one y coordinate. So an example is if the function was y equals to x plus 1, right? And I substitute x equals 2, then the y value for that corresponding x value is when I put x into it, 2 plus 1 gives you a y value of 3. Notice that for one x value, you only get one y value. So this is a function. What's special is we call this a one-to-one type of function. Okay? And the reason why is we know it's a function because there's only one y value here, but it's called a one-to-one because that's for every x value, you're only going to get one y value. So for one x, you get one y value. That's why when you see, as soon as you see that this says 1, whoops, I don't know why it's so slow. I literally clicked on it. When it says 1 for the y section there, okay, so this is the y section. When it says 1, it's automatically a function because we said by definition, a function is when the resulting value is only going to be one y value. So that's why we know this is a one-to-one type function. Oh, sorry, we know it's a function, but specifically it's a one-to-one. Whereas you can have a different type of function, so it's still a function. What is that? So here we go. Let's have a look at an example. If I gave you y equals x squared, right? That's my machine. If I decide to now put in x equals to 3, you see that will spit out a y value that is 3 squared, which is 9. Great. So 1x gives me a 9. That seems to be a one-to-one, right? But you also know that if I sub in x equals to negative 3, that also gives me a y value of 1. So this is still a function because there's only one y value that's coming out, right? Even though I've got two x values that I'm putting in to give the same result. This is what we call a many-to-one type of function. You see, because again, as soon as you only get one y value for it, and you can picture the graph as well, if you actually sketch this, sketch the parabolic shape, you can see what I mean. You see, if we did a vertical line test, you can see that it only crosses once, but if you do a horizontal line test, it crosses twice, which implies that there must be two different x values for the one y value. As soon as you see there's only one y value, we call that a function, and then the many x's is the different type. So in our case here, we've got a one-to-one type function, or you can have a many-to-one type function. A one-to-one type function would be something like a linear equation. So a linear equation only has for every x value, you only get one y value. Okay? So that's a typical example of a one-to-one, whereas the one I just drew here is a many-to-one function. And then you got another two types. We call it in total types of relations. There are 4 types, yeah? So you got a many-to-one or a one-to-one, but you can also have a machine where you put in an x value. So say you put x in, so one x value, and it spits out two y values. An example of that is something like y equals to root of x. So a square root relation is an example. So if I put in x equals 4, we know that the square root of 4 is not only 2, it could also be negative 2. So as a graph, technically a square root relation should look something like this. So at 4, you should have either the coordinate, when x equals 4, it's either 2 or it can be negative 2. So you can see there are two y values there. That's why it fails the vertical line test. If I did the vertical line test, you can see it crosses twice. So this is a relation. So we call this, what type of relation is this? We call it a one-to-many, not function, relation. So there are 4 types of relations. I'm just going to take this out so it doesn't confuse you. You have a one-to-one, a many-to-one relation, and a one-to-many there. But out of these two, these are functions. So out of those relations, only these two are functions because you only get one y value. Whereas over here, notice here says many, which means you're going to get many y values, and that's why you got y equals 2 or y equals negative 2. So that's an example of a one-to-many. And your final example is you might have a machine, right, where multiple x's can get you multiple y's. Same y's and it crisscrosses. Okay, so for this one x, you can potentially get 2 of these y values. And then maybe for this x, you can get, these 2 x's can get the one y value. So it's a many-to-many example. So this is what we call a many-to-many relation. So as soon as you see this word saying many, that's a relation. So this is a type of a relation, and function only occurs, I mean, they're all relations, but out of all the relations, there's only 2 out of the 4 types that is a function, okay, by definition. So what's an example of this? This would have to be a circle, which we don't learn anymore. But in a circle, you can see that a circle, for one x value, you can see that there are 2, it fails the vertical line test, but you can also see it also fails the horizontal line test as well, crosses twice. So a circle is an example of a many-to-many. Okay, so it's a many-to-many relation, a one-to-many, many-to-one, and a one-to-one. And the key thing to remember, how do you know it's a function? Look at that y part, the y component, 1, 1. When it says 1 as the second part of it, that's a function. That helps you understand the definition of function. Okay, so here you see that they try to teach you how to use a horizontal line test. The horizontal line test, if it crosses twice, this is an example of a many-to-one. See, if it crosses twice, this implies that it takes 2 x values and it has only one common y value. So that means when you put in 2 different x's, you can get the same y value. So this is a many x's to one y value. That's why we call this a many-to-one. So the horizontal line test is only to check if it's a one-to-one. If it crosses twice, it's not a one-to-one function. Okay, this is clearly a function. If you do a vertical line test, it only crosses once. So a parabola is a function, a quadratic is a function, but it is a many-to-one function. So here, I'm going to write here, many-to-one. Oh, well, they said not one-to-one. So you do a horizontal line test, crosses twice. Horizontal line test, yes, it's a one-to-one, only crosses once. Okay, over here, is this a many-to-one? Yes, because as soon as you cross it through, you can see it crosses infinitely many times, and it just simply means that when you pick x equals 0, you get a y value of 5. So 0, 5 is 1, and then another point here, let's say you picked 5, this would be 5, 5 again. So that means that you can pick 0, x equals 0, or x equals 5. The resulting is one y value of 5. So that's why we call this a many-to-one type function. Why is it a function? It's because the vertical line test, we can see that every x value has a unique y value. Okay? Or at least one y value. It doesn't, if you choose one x, it doesn't spit out 2 y values. All right? So vertical line test tests if it's a function, and a horizontal line test tests if it's a one-to-one or not. That's essentially what it is. Okay, so hopefully that understanding helps you, but there are 4 types of relations in this exercise, and then you'll be using that knowledge to then answer these questions here, which I've done videos for. Okay, now implied domain, I did do an example 15. Implied domain essentially means without them telling you what the domain is, what's the domain, what's the restriction? And an example is something like a square root function. There is an implied domain. You see, when you sketch it, it's very obvious. A square root function, we know that we can't square root negatives. True? So already the domain is implied that it can only be from 0 to positive infinity. So we say the implied domain is x is an element of 0 to positive infinity, or if you like, you can use set notation saying positive or